Anyway, let's go over to server-side request forgery. In essence, what I've shown you with the XML external entities is a kind of server-side request forgery. Server-side request forgery means essentially I need to tell a server that it loads a certain URL for me, it does a certain thing. And as you've seen from the other things that Yanis, for example, showed before, cross-site request forgery, for example, or other parts can be nicely used to also be able to see certain things that are making it problematic to do server-side request forgery, which means in a sense, if I'm able to have a cross-site request forgery problem somewhere on some backend server, and as I said, it could sit in some forgotten corner, but now I can trick, like for example, a Solr server or Log4j server to make a request to that. Suddenly I get an exploit opportunity in an otherwise open system. So what has changed over the last years is that we don't have this like little silos anymore, where you have a server and it's configured with MySQL, Apache, PHP, etc. like that, like the typical LAMP step, Linux, Apache, MySQL, PHP. But what we see now is that the world gets a lot more complex, especially with Kubernetes, CloudFormation things, etc. like that. So it's much more often happening that we are fetching things from another server just to be able to see things like that. And I think that's a really important point here. That's why it was not there. That we need to really ensure that no one is doing outgoing things. And one of the easiest things you can do is to add ACLs to your servers. For example, at a large enterprise client, it's absolutely standard security practice, and we do that for our properties as well, to just not allow access to the internet from a server. This can feel really, really bad at first because, hey, how can I do updates like that? How can I do like an apt-get update, RPM update, whatever? How can I do other things? But if you have only trusted endpoints that you can reach from a server, your attack surface vanishes a lot. Because if from that one server you've been able to trick it into doing a server-side request forgery to make a request to something in the internal network, it cannot access anything in the internal network except itself and maybe its other webhead peers, then you did not win any kind of privilege escalation at that point. However, if there's no firewall rules and you can have everything outgoing to that, I could access a Memcache server that's sitting somewhere. Maybe I could try to get access to a Redis instance that's not password protected, something like that. A lot of that can happen. And that brings us to the next point. To prevent server-side request forgery, the next important thing, besides trusting your input or trusting that you've correctly checked your input. So not trusting input and knowing which input you can trust and which input you can't trust. It's very important to also see that you are not allowing like things like an open password. Because, for example, if you had a memcached running and the webhead can access it because it needs to do cache get, cache set requests actually, and you have the server-side request forgery where someone can do a little request to the memcache and get some data back, then you've opened your door much more than if there's a password in front of it and someone would need to use an API function to actually do this access. Or, as we said already earlier with the XML external entities, settings PHP or password.php or whatever the web server needs to access the MySQL. And again, you have more credentials. So, yeah. But going back to this trusting of input again, the most important thing is to never trust anyone. Because, for example, let's say there's a trusted peer who's sending you log messages. And you're saying, hey, log messages are fine, they're just log messages. What could ever go wrong? And as we've seen in the log4j example, a lot can go wrong, because the log4j can actually lead to some unrelated system doing something, but you've trusted it because it had been just log messages. There's nothing wrong about that. Or as we saw in the XML example, let's say you're expecting HTML from some other trusted source, but suddenly that trusted source had an exploit, and while their system, you could not really do something, but because you are receiving this HTML and you have like this XML entity problem, suddenly this trusted system sends you untrusted content, and it leads to a much larger security problem than if you had said, hey, I think this is a trusted system, but trust, but verify. And I think that's much more important here as well. In terms of XML entities, you can determine the schema before. There's some nice code for doing that. In terms of external links, you can check that those links are only to things you want them to go. In the terms of MySQL strings, like a MySQL injection, you would validate that. But another nice server-side request forgery is, for example, Apache Solr. If you were to able to trick a web server to make a certain request to Apache Solr, you could, for example, make it rebuild a dictionary. And because that takes a while, and if some service depends on this dictionary being there, like for autocomplete or suggestions, then you could even denial of service this Apache Solr server just by sending it, hey, rebuild it, rebuild it, rebuild it, rebuild it, again, again, again. And this is kind of like what they're saying here. It's not enough to just deny based on regex or whatever, because people are finding very, very creative ways around it. Log4j, it was solved 3 times because they were like, hey, we've mitigated that yet. And then another thing came in. And Log4j, by the way, was very similar to XML external entities. Again, you were able to reference something external, which was then part of your log message here. Just a Java default functionality, very useful, but not as useful for this case here. And but here they are also saying you want to log all accepted and blocked network log flows on firewalls. So if you see something like, hey, there's someone trying to access something that they shouldn't from the internal, it's a very nice first step to block it. But the next step is to also log it, because that gives you an idea of that you are dealing with server-side request forgery. So security also always means to have a telemetry system. So you have always this kind of level of noise, of errors happening. But if there's a lot of errors suddenly happening at a point, and you're logging these like ACL failures, for example, then you know either there's a bug in your application, which is really good, or you know, hey, there's someone trying to hack me right now. And that's not a good idea. So yeah, again, from the application layer, just I've covered a lot of that already. You want to sanitize and validate everything, verify everything, even if you think it's a very trusted server that's sending you the data and it uses XML on the HUD or something else, validate it, ensure that what you are getting back is what you expect and is not completely something different. Another example, never ever ever send serialized data, PHP serialized data across the wire, because it's so easy to exploit. It's like, a cache might be still okay, or MySQL, because, well, there you know that you've serialized that, but in theory, even that is already a little bit insecure. Because what you would want to do is you want to sign, and often you don't have the time, or you don't use the computational effort. But in an ideal scenario, anything that you serialize as PHP, you want to cryptographically sign, because if anyone is able to change it, unless they have the key, they are not yet in. And if they have the key, you have other problems anyway. Then it's also important, do not send raw response to clients. We've covered that a little bit already in the security misconfiguration. That's really important to not just have logging enabled, because for example, if it has like, hey, Apache Solar sent back the message that here's your etc password, and that's a very error, and you're showing that to the user, well, now you've exposed what before would not only have been ended up in some log file to the attacker. So that's not a good idea. HTTP redirection is also an important thing. A lot of classes within Drupal security problems, we covered that on previous security trainings, has been to trick Drupal into using a destination parameter that was then redirecting someone to an external attacker site. So I'm sending you a link to drupal.org/very special parameter, and then you think you are still on drupal.org, but you are in reality you are on Drupal attack.org, and you're not seeing it. You're putting in your password, etc., and I've successfully done a phishing attack. So it's really important. Yeah. Another important thing is you could trick someone, and you need a lot more infrastructure and knowledge for that. But for example, you could trick someone to trying to get them to a bad DNS resolver address. DNS is still often unencrypted in the internet. So that's a really important part to think here about. And if someone is able to get into your local network, for example, they can spoof DNS responses, and if they are then not using TLS to, for example, access your Redis cache server, you could be accessing the attacker's cache server instead. And that's also why you should never store sensitive information in caches or whatever like that. Just as an aside. Yeah. Oh, and the other thing is VPNs. If you're using Docker for example, for that, one of the most interesting server-side request forgery happening is that someone is attacking your local system that is on a VPN. So some bad actor within a corporate VPN, there's obviously none, we all know that, but just assuming that, is able to hack your local machine, and via that they can then hack further into the network. Yep. And yeah, I think that would be it for server-side request forgery. We're also out of time, so that's a good time to stop and maybe take some very last questions.